The question was, what is the force on, and I named 3 of the balls, I forget which ones, but I'm going to do the upper left-hand one, that 3 times 10 to the minus 6. I'm going to have a force of attraction from the 3 guy to the guy that's down below the 2.4 negative. I like to think of this guy right here as home plate and then first, second, and third base, but we're going to use the labels that they gave us. How do I know that the 3 guy gets pulled downward as opposed to gets pushed upward? Opposites attract. Great. So I have a force that's going to be pulling me straight that way. Okay, what about third base? What's he going to be doing? Is he going to be pulling the 3 guy to the right or pushing him to the left? Pulls him to the right because they're opposite charges. Great. And I'm also, of course, going to have an attractive force over here to the minus 9. So what I need to do is figure out if I add the red and the green and the blue, what does that work out to be? That's where we're going. So I would like to first of all figure out what the force of a 3 is on the 3 due to the guy right below in the minus 2.4. So we're going to plug and chug. 9 times 10 to the 9 times the charge of the guy I'm talking about, 3 times 10 to the minus 6, times the charge of the other guy that's pulling him, 2.4 times 10 to the minus 6. And the distance between them is 15 centimeters, but because we're not dorks, we convert to meters. Now you'll notice, please, that I did not write minus 2.4. I did that on purpose. This is my 12th year teaching the course, and I have found that it is better for students just to keep it all positive. Take the magnitude and then use the brain that God gave you. We just used the brain that we were given to say, oh, it pulls us downward. So find the magnitude and then later figure out which direction it goes. Question. I punched my numbers in. I got 2.88 for my magnitude. And I like to put the little arrow to remind me what the direction is going to be. Downward. We'll need that information later. Let's calculate the next 2. Okay, plug in the guy on the right, 9 times 10 to the 9, times my original charge of 3 microcoulombs, times the 6 microcoulombs. I realize it's negative, but we'll worry about that later. And the distance between them is 15 centimeters. Okay, 7.2, and we already decided from before that it moves you straight to the right. Let's do the last guy, the blue guy, the minus 9 in the bottom right-hand corner. Okay, I have 9 times 10 to the 9, multiplied by my 2 charges, divided by the distance between them, squared. However, I made a rookie move here. Let me find my rookie move. There's something wrong on there. Brian? It's the diagonal. Excellent. It is not 15 centimeters from here to here. It's 15 centimeters square root of 2. Right? It's an isosceles triangle. So let's go ahead and do a little bit of erasing here. Square root of 2 squared. Now we'll try it. So 5.4 in the, basically down at a 45-degree angle. So let's see what we have up to now. We have our 5.4 in a 45-degree angle downward. We have a 7.2 straight to the right. And we have a 2.88 going straight down. Let's add all these bad boys together. On our first one, the 2.88, it did nothing on the right and left. It pulled me 2.88 downward. That's why I'm going to put the minus sign on there. Because we adopt the convention that anything that is down is negative, anything to the left is negative. Please note there's nothing religiously sacred about that. It's just we all kind of agree to adopt that convention. We could do the other as long as we all agree to it. Okay, pulling it straight to the right, we have 7.2. But it doesn't do anything downward. Why is the 7.2 positive, not negative? Pulls it to the right. Great, thank you. Finally, I have, was it 5.4? Yeah, okay. 5.4, pulling it straight to the right. So I have this. Actually, not straight to the right. It's 5.4 this way. This is a 45-degree angle. So it's 5.4 cosine of 45 degrees and 5.4 sine of 45 degrees. Now, some of you are getting nervous about splitting this. My apologies, but you have seen it many times. It's chapter number 11 in your Algebra 1 book. It's chapter number 9 in your geometry book. There's a reason they call it Algebra 2 trig, and those in pre-calc, you're getting it again. This is nothing new. Oh, by the way, it's also chapter number 3 in your physics book. We've done these before. So this guy over here is cosine of 45 degrees. And this other guy over here is sine of 45 degrees. See, it's 5.4 cosine of 45 degrees is moving you to the right. The other guy is moving you downward, so you do the negative. Now you add. Wait. This works out to be, oops, try again. This works out to be 6.7 this way, negative. And this is 11.02, so we're almost done. You go 11.02 this way. You go 6.70 this way. Now you use the dead Greek, dude. Cha-ching. See you, babe.